solve the given initial value problem using variation of parameter method. So here's the steps you need to do. First, find homogeneous part, then non-homogeneous part, and add them together, which gives you final answer. Okay, so let's work through it step by step. So here's the problem, and the condition is this. First, we need to have a minus lambda I. And what is it? It is equal to this. Let's call this matrix A and then subtract it with lambda. That gives you this matrix. Okay. The reason I didn't write it down because I'm familiar with it, but for the purpose of clarification, some of you may not see it, so that's why I have to write it down. Alright, so here's my A minus lambda I. First, take the determinant of it. It gives me this one. Set it equal to 0. So for lambda, I get lambda equals to 4. For lambda equal to, plug it into A minus lambda I. That gives me this matrix augmented with 0. From the first equation, I know that k1 is equal to k2. If I choose k2 1, then k1 is 1, and my vector k is 1 1. Then my vector x1 is 1 1 e to the 2t. You are going to do the same thing for lambda equals 4. You plug it into A minus lambda I. That gives you this matrix augmented with 0. It gives you this matrix. From the first equation, I know that k1 is equal to negative k2. If I choose k2 1, then k1 is negative 1, and my vector k is negative 1 1, and my vector x2 is negative 1 1 e to the 4t. Then my homogeneous solution is equal to c1 times vector x1 plus c2 times vector x2. Alright, now for non-homogeneous part, similarly like A minus lambda I, first you need to have a matrix in terms of t, which I call vector phi of t. So basically you exclude c1, c2, and bring down the rest. Then you need to find the determinant of phi of t, which gives you 2e to the 6t. Then its inverse is equal to 1 over the determinant times this matrix, but you need to change something. So in the upward diagonal line, you are going to multiply by negative 1. For the downward diagonal line, you are going to switch their positions. Okay, multiply these together, it gives me this matrix. Then we are going to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this matrix. Multiply them together, which gives me this matrix. Okay, then after you have vector u prime, you need to integrate this one to get vector u. Okay, so that's easy. Now for your non-homogeneous part, it is equal to phi of t times u of t, which is this matrix. Then your general solution is equal to non-homogeneous part, which is s1 plus homogeneous part. Alright, normally you would stop right here, but because you are given initial value problem, so you have to solve for c1 and c2. Okay, so using the condition that vector x is 0, plug in 0 for t, I get c1 times vector 1 1 plus c2 times vector negative 1 1 plus 0 2 equals 1 1. Okay, now let's put this into a matrix. You can solve it. You can solve this one using a system of equations, but I like to use matrices here. Okay, so 1 1 negative 1 1, and combine this together with this one. So basically you take this matrix, subtract this one, that gives you 1 negative 1. Okay, and then reduce to epsilon form. It gives you c1 0 and c2 negative 1. Then your when you plug this back into c1 and c2, you will get this one. Okay, and I see that I have e to the 40 here, so combine these together, it gives me this one. And then here, let me say it one more time. So I see that this one has e to the 40 and this one has e to the 40, so combine them together, which gives me this matrix, and here's your final answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.